Okay, I think we can get started. Thanks everyone for joining this first webinar that we have. We are excited to start or kick off this new task force. It's an IEEE Power and Energy Society task force on foundational models, which is one of the hottest topic right now with all the buzz around ChatGPT, foundational models, multimodal models, and so on. So we're really excited to start this task force in order to promote collaboration, promote knowledge exchange about this topic and what its application is for grid operations and planning. So we have this task force called Foundational Models for Situational Awareness, Computation and Analysis. It comes under the CAMS subcommittee, which is the IEEE PS Computing and Analytic Methods CAMS subcommittee. Um, so first off, I just want to give a brief introduction of the task force, and then we'll move on to the webinar. The scope of the task force is anything related to foundational models, multimodal models, large language models, small language models, and all the developments that have been that have been happening in the generative AI field. And really, our goal over here is to promote exchange and be this medium through which we can disseminate research and the current developments in this field. I personally think it's a very important development which has happened on the foundation models. But the question is, how can we harness that, or how can we use those advancements for grid operations and planning and analysis, computation, and so on. There are different challenges, there are different opportunities and benefits. So we want to, be a medium where we can discuss about these topics and really try to foster collaboration between the people who are developing these models and the grid community. We have a lot of things planned: papers, webinars, panel sessions, and so on. I just want to give a glimpse of the near-term activities that we have, as well as some of the long-term. So we have today this inaugural webinar. We have speakers from NERC and GE Vernova who are going to be presenting their perspectives on this topic, as well as introduce or talk about a couple of white papers that they've been working on. The IEEE Power and Energy Society General Meeting is coming up later at the end of July. We will be having our first in-person meeting of the task force, that is on July 29th from 11 to 11:50 a.m. If you are attending PS general meeting, then please try to attend the meeting so that we can meet in person. We also have a panel session at the IEEE PS general meeting. It is on large language models, where we have experts from the industry, experts from NERC, expert from vendors and national labs talking about the different perspectives of large language models and their applications, use cases, benefits. Moving forward, we'll be having monthly webinars. We are in the process of setting up those monthly webinars. So once we have that, we'll have experts across the different industries come and present and talk about the work that they're doing. And lastly, we have also planned technical papers, which will be starting soon. In terms of communication, we have a website, so you can go to the website, and we have some preliminary information over there, and we'll be posting all our information on this website. If you want to stay tuned with the activities of the task force, then join the mailing list, and we'll make sure to send you information about the activities of the task force and what we are doing. Um, all the webinars that we're having or plan to have will be recorded. We have set up a YouTube channel. So once the webinar is over, we'll upload the recording to the YouTube channel, and so that you can take a look at it at a later point of time as well. All right, with that, it is my utmost pleasure to introduce today's speakers. Today we have an exciting presentation. The title is Unlocking the Language of Energy Data. We have three speakers who are going to be presenting their perspectives. First, we have Wei Qiu, who's a lead engineer at NERC. And Wei holds the position of lead engineer for event analysis within the Reliability Risk Management Group at NERC. He is additionally the coordinator for the NERC EMS working group. With him, we have Larry Collier. Larry has been with NERC for 3 years, serving on the security integration team. He's the coordinator for the security integration and technology enablement subcommittee. And at NERC, he's an OT ICS cybersecurity specialist. And our last speaker is Thomas Peterson, who serves as the vice chair for the NERC Sites Subcommittee. And he's a principal product cybersecurity leader at GE Vernova Electrification Software. So with that, I'd hand over to Wei and Wei, Larry, and Thomas to present your thoughts on this exciting topic.
Hey, thanks, Sri. So
Yep.
let me share my screen.
Yep.
All right, you guys see me screen, okay?
Yep. It's
All
not
right,
full screen,
so
though.
let me go to the presentation modes. Okay, let me try. Okay. All right, thank you, everyone. Really appreciate these opportunities here, and thank you for taking the time to join us. Just like Sri mentioned, my name is Wei Qiu. However, my last name is Qiu, not Qui. So make correction, Sri.
I apologize.
No worries.
Okay.
Just to let you know that. So
Yeah.
today, my name is Wei Qiu from NERC. I joined by my colleague Larry, also from NERC, and also Thomas from the GE Vernova. So very glad to be here today, and we will discussing how we can better understand. Did I turn on the video? So sorry. Okay, so we will how could we better understand, deploy, and involve the language of energy data, particularly as AI and machine learning become more permanent in grid operation. So we will going to walk you through the real world insights from our work, including findings from two recently published white papers. All right. Okay, here is an agenda for today. So first, a quick introduction about NERC, about who we are and what we do. So then we will explore the two white papers developed with the input from industry. One focus on application of AI and machine learning in real-time operations. And then another is centered on the mechanism for field trial of the emerging technology. Throughout this presentation, we will highlight examples, industry feedbacks, and the lesson learned. And at final, we will reserve time for your question at the end, just like Sri mentioned. So please drop your questions in the chat box as we go. We will answer at the end of our presentation. So let's take one step back to the time, to the November 9th, 1965. On that day, a massive blackout swept across the northeastern United States and a part of Canada. On that day, this left 30 million people in the dark and cost about 100 million in economic losses. This blackout also served as a wake-up call for the electrical power industry. So in response, the Federal Power Commission recommended formation of a council on power coordination. So that recommendation led to creation of a National Electrical Reliability Council in 1968, which eventually became NERC. So in 2006, which is 3 years after the 2003 blackout, NERC's role was formalized by Congress, designating as an electrical reliability organization for the United States. So this history matters, right? So this underscore our central mission is keeping lights on and ensuring what happened in 1965 and 2003 never happens again. So today, NERC is known as a not-for-profit international regulatory authority. So work as the ERO for North America is a subject oversight by FERC and the governmental authority in Canada. So our responsibility include the develop and enforce reliability standards and also reliability assessment. So we have a long-term assessment, short-term assessment, winter assessment, and also and summer assessment. I think a couple of weeks ago we published 2025 state of reliability, which is example assess the system behavior in 2024. So we also monitor the ballpark system through a situation wellness. So like IBR issue and the large load issue were identified during event analysis. And also we have educated, training, certified industrial personnel. So in the short, so we exist to protect the reliability and the security, the grid, which is a backbone of a model society. Okay, so we carry this work through the partnership with 6 regions. From East Coast, we have a Northeast Power Coordinating Council, NPCC. We are Reliability First, RF. We have a CERC Reliability Cooperation, CERC. And there was a Midwest Reliability Organization, MRO, a Texas Reliability Entity, TexRE, and Western Electricity Coordinated Council, WEC, or WECC. So each of these regions has their own structure and operating conditions. So, but they're all part of ERO enterprise. So together, NERC and the region oversee all the electricity supplied in North America, from the Northern Territory, Canada, to the Baja California in Mexico. So this is a little bit introduction about NERC. So now let's switch gear and talk about how emerging technologies, particularly AI and machine learning, are starting to transform how we operate grid in the real time. So this session is based on our recent paper, a white paper, so which explored not just what's happening in the industry, but also how to navigate it responsibly. So what we see in this shift from our traditional operator workflow to data-informed decisions support tools. So this shift brings both opportunities and challenges. So this white paper was published last year. I leave the QR code here, so I pause it for 2 seconds. If you are interested, you can scan this QR code and serve for the review these documents after this webinar. All right, so let's move forward. So this white paper, the purpose including 2 parts. So first, we know real-time operations change, right? Getting more and more involved, more new advanced technology. And the ERO members also looking at using AI and machine learning. So, however, there are lots of confusion and buzz around about what AI and machine actually meaning in the power system operation. So we want to cut through this noise and explain in clear terms what this technology can do, this technology can do, and where they fall short, and how to make sure we implement this technology effectively and properly. And the second, we want to help industry leaders to think about the organizational changes required to support AI. The changes including in the mindset, infrastructure, and the trainings. And the trainings. So we see a lot of tools treated as black box. So operators often don't know how they works. So this can lead to the mistrust and the misuse this AI or the machine learning tools. And as part of a white paper development, we interviewed the a lot of broad cross sections from the reliability coordinator to the vendors to utility executives. So several constant themes that emerged. So like some tools declare they use AI or machine learning, however, actually they are not. So some use it, but the vendors didn't tell us or tell the entity how this tool work. And some organizations are using AI without the notice. So there is clear need for transparency and explainability. Without this, so it is hard for operators to trust these tools or to integrate these tools into the workflows. And also, we conduct the detailed industry survey. So what we found both encouraging and cautionary. So you can see 53% the respond have some form AI or machine learning policy or the guidance. 38% using these tools for the prediction task like forecasting, and 30% were banned on the public tools like ChatGPT due to the cybersecurity or compliance reasons. Also, we see some the most common application use cases like system load forecasting, renewable generation prediction, and the cybersecurity. You can see this area is where the AI can process large data set quickly and identify the patterns that humans may miss. Also, we also look at how different the utility functions are used in AI. The functions means reliability coordinator, TOP, balance authority, BA, those things. So some utility like the RC or they're applying something is in the real-time application, or some using AI for internal tasks like documentation summarization or cost the optimization. So here is one thing I want to point out here. So these tools need continuous tuning, not just one shot at the beginning and that tuning works forever. So the engineers must configure them and the operator must oversee them. So we'll see tell us the AI doesn't replace human judgment. It's just augments it. And also there's a lot of many use cases already in production. Here's for example, MISO already developed AI-based load forecasting model for improving the forecasting accuracy due to during unusual system conditions. And the PGM has adopted similar things for the integrating the renewable variability into the models. So these are real cases already use it. And also we see the potential we can use is like solar and wind forecasting, contingency stability analysis, and the EMS planning model and the system operator training. So I am an EMS guy, so I will I do have some bios here, so I will see the let's example say the contingency stability and analyst. So now the traditional contingency analysis like RTCA or study CA, so they have a predefined contingency set, right? Really defined a long time, maybe over thousands, 10,000s, and they're running every time. So however, they lack to some the dynamic identify the new contingencies, right? So maybe based on this operation the condition, maybe some contingency need to add to the set. So far I think traditional legacy contingency analysis cannot do that. And also the legacy, the contingency or traditional analysis just tell you what's wrong, and some label say, hey, I have some thermal existing, or maybe I cannot solve, and due to voltage issue. So, however, the main could not provide is a mitigation strategy, right? So provide maybe pre-contingency mitigation or post-contingency mitigation. So if the AI or new tools can provide the not only labor labeling issue, but also provide the mitigation strategy will definitely significantly assist the system operators and to deal with these issues. And also you can see this value as work as tools, not replacement. And these tools add tools for skilled people decision makers. Now we see a lot of good things here. So evaluate the roles AI in the power system operation, but we also is critical to examine the risks, right? So as do so this systematically. So the DOE CESER office, in coordination with the Lawrence Livermore National Lab, identify for the key category of risk associated with AI in energy systems. So this category is not just theoretical. It's a real concern emerging from the industry. So first is explainability and transparency. So it is most commonly concerns many UI, especially those based on I think deep learning. So we call it black box, right? So operators can see the input and the output, but not why the behind the decision. So for example, the contingency, so you use this AI to label something wrong, but don't tell you why. Is problem, I think. So without the traceability, operator cannot verify model logic and make it difficult to trust and take action on these results. And the second risk is the integration and operational compatibility. So AI tools cannot live in isolation, right? They have to fit in existing system like EMS, SCADA, planning tools. So the legacy system may not support this AI tools or cannot handle large data volumes AI model request. So even when this tool integration is technically feasible, operational teams must adjust their workflow and retraining on the new phases. And the third risk category is the governance and the policy gap. It's just basically oversight and accountability. So sometimes we need to ask, so ourselves, or maybe when you develop AI tools, so who is responsible if AI tool that leads to the wrong decision? And also, should we have a same virtual control, version control, validation, and audit requirement as to this AI model as same like the other optional tools, right? Many of we see in many organizations don't yet have this formal governance structure in place for AI and machine learning tools. And without clear policy on the testing, deployment, and the monitoring, we risk regulatory exposure and internal confusion. And the last risk we based on the CESER office is cybersecurity, right? So AI system involved like data aggregation, the cloud computing, and external libraries, right? This is also increased the attack surface. So this AI system must be protected, just like the other critical infrastructure tools. So maybe I think you need more structure protect. So these four risks here enforce one. I think this four risks categorize explainability, integration, governance, and the security enforce one common theme. So AI is not plug and play, right? They need the deliberate, secured, and the human avoid the deployment. So just like we won't implement a new SCADA or EMS system without testing and the safeguarding. So we should not implement AI and machine learning tools without a robust framework for validation and control. So now we identify the risks. So the natural question is, what can we do about that? this answer is not just about the technology. It's about building the right foundation for using AI responsibility and also effective real-time grid operation. So I think we group our recommendation mitigation to the three buckets. So first is the skill set. So it's about the training and the workforce. So AI is not useful unless people know how to use and know when not to use. So operators, engineers need the foundational training in the AI and the machine learning concept. So, but this doesn't mean they have to become the data scientist experts, but they should understand like a model inputs, confidence intervals, and what is abnormal score means. And also we see that some needs for the cross training. For example, like IT staff may need to understand the grid operation. System operator may need to understand the cyber risks. So, and for the mindset is for that we create as for certain culture of the AI readiness. So we believe the technology adoption is more often about people, not the system, than the system. So AI solution work best when we have some culture for curiosity, transparency, and the measured experiment and measured the experimentation. So this means we should challenge this result. We should ask a lot of tough questions. Said like why this model make this recommendation? Can we trust these results? Right? Because this means create a lot of space for safety trial of the error with clear boundary. And the elements mitigation is a tool set, right? Build security transparent infrastructure. So we should have a data governance and also codification. We should have some infrastructure readiness from the high performance computing to secure API, integrating the model to our real-time dashboards, right? So together, these three elements, skill set, mindset, and tool set, so create a strong foundation for the safe, scalable, and sustainable AI use. AI and machine learning are not just new tool. They represent the paradigm the shift in how we engage with system data, risk, and decision making. So getting it right is critical important for the reliabilities as a grade evolves. So what is our top recommendation here? So basically just to keep system operators and engineers in the loop, right? Operators need the time to review these systems and in a way to align with reliability goals, right? Just I mentioned the system, the operator need to oversee the system, the engineer need to configure, and also the training and the cross training is needed. So moving forward, so collaboration across regional vendors and the policymaker is pretty important. The next step at our NERC side will continue to convene this conversation, not to just guidance policy, but to inform practical and on-ground implementation. So if you pay attention, this the white paper we published last year's version 1. So we plan to refresh this old document every other years. Right now we're looking for lots of actual implementations and the changes, and also some new technology from our industry and also from the AI and the machine learning the tools we can add to our next version. So I think this is all about my presentation. Now I will turn this webinar to our colleague, Larry. Larry, I'll turn the meeting over to you.
Thank you, Wei, so much. All right, so I'm just taking a look at the time. My deck is really about giving you guys an idea of kind of how this conversation moves through our NERC supported committees. You can go ahead and next slide, please, Wei. And but I'm going to try and move through this pretty quickly because I really want to get you guys over to listening to Thomas Peterson, who's got a lot more interesting conversation directly related to this webinar on foundational models, AI and ML, and sharing insights that are coming out of the site sub-team on AI and ML. But just a little background. So site's Security Integration and Technology Enablement Subcommittee, a bit of a mouthful. It kind of got its origins, I think, about 5 years ago out of a SIP working group committee that got reorganized. It is under the RSTC, and it's open membership. It depends upon its volunteers, and our goal is really twofold. Security integration in the first half is the idea that we are looking to integrate security into the traditional practices of grid planning, design, and operations. There's a TR 105 report that came out jointly from NERC and IEEE a couple of years ago that really put that was kind of part of NERC's initial strategy to bring that forward. And then, of course, the RSTC adopted that as part of its work plan strategies under sites. The second component of that is technology enablement. Next slide, if you don't mind, Woody. And technology enablement is really about looking at these emerging technologies. Cloud was a huge one, as well as AI, synchrophasers, DER. Sites is looking at all of these things, trying to break out of the traditional mold of being a technical committee where the prominent expectation is that we're 100% regulatory standards focused, right? SIP focused, for example, in the security side. And we're trying to bring those conversations to be much more broad, much more engaging, in part because there's a lot of work that goes into the discussion and the engagement in industry to solving problems, understanding challenges, just illuminating information around new technology and technology-related security issues well in advance of a standards, a SAR being developed and approved, right, to drive regulatory changes. Not all problems require regulatory standards changes, but sometimes the answers need to actually be developed, and there needs to be a lot of effort and consensus to build towards that. So sites is attempting to do that. We are still in the realm of building technical justification for SARs and commenting on standards related issues. Next slide, please. So a perfect example of what sites is doing is a white paper that was released, I believe, December last year, new technology enablement and field testing. This white paper is really highlights sites' call to purpose around having the conversation within industry on what are those drivers for innovation and drivers for adoption. What's the relationship of those drivers with our regulatory framework, our regulatory processes, the way that we interact and build consensus in the industry, and the relationship that our technical committees under the RSTC and other NERC supported committees, how they play a part in that whole ecosystem, right? But as well, some looking at some of the behaviors that we see in industry around technology adoption, innovation, and regulatory compliance, and how that kind of affects things like cloud and virtualization, experience of perceived lagging, adoption or lagging integration into our grid operations and processes. So we're trying to move the needle. We're trying to find out what moves the needle and how to become more efficient and more secure and reliable along that pathway. So this white paper dives into that. right? It does attempt to break out of the mold and have those conversations, not about having the right answers, but having the conversation itself. And a big component of that is leading to a major recommendation in the paper about a program called Retina. Next slide, please. So the a major component is this recommendation for field trials in a way that are distinct and separate from the existing field test process that exists under the um, rules of procedure, which essentially is tied up in the standards development process, requires a SAR already to be established. But as we know, some technologies that lag behind, and cloud was a major driving force behind this white paper in its initiation. There was no SAR on the horizon for many, many years. And the reason why is um, just, building enough consensus and conversation and technical work around the problem uh, is much of what we identified as part of the tricky issue with achieving adoption and achieving that movement of the needle in getting our regulatory standards, standards updated in a way that allows for that adoption in a secure and reliable way. We identify that's not so simple as a technology being blocked by a standard. Sometimes it's just the ambiguity and the uncertainty around how that technology plays into the grid, how it plays into security, how it plays into the standard's existing interpretability. So this just highlights the need for these conversations to happen. But going further than conversations, sometimes you need to test technology. And what's crucial is around this white paper and around this field trial recommendation is that we find a way to take the disparate efforts that happen around industry uh, in different groups represented by different organizations and bring as much of that centralized as possible, encapsulated under the conversation of regulatory um, engagement and oversight by regional entities, by NERC, not necessarily having a heavy hand, for example, in the process, but that there is a conversation where the information is being shared and is going to working towards a process of building a justification for whatever's necessary to move that technology forward into a real adoption space, i.e., if that means having a SAR or if that means having, eventually developing into security guidance or implementation guidance without standards changes so that we have a clear understanding across the industry of how that technology can be used in a way that supports compliance, in a way that achieves reliability and security. And the field trial recommendation is key to that. It's we want to see a groundswell of this effort. We want to see engagement with the regional entities and NERC, and we want to see industry come together and be unafraid to build a process around testing new technology in advance of regulatory standards development in a way that's secure and reliable, and in a way that transparently brings information forward for the industry to benefit from. Next slide, please. So, why are we talking about this, right? Why do we even care about all that? Because AI now, just full steam ahead is one of the most disruptive technologies that mankind has ever seen, and it promises to continue to be. Um, and our industry needs to be prepared to handle it. As Wei spoke about some of the challenges and some of the implementation, there's still a tremendous amount of open-ended questions. Uh, Thus, the need for this webinar. what currently exists in this technology today, 2 years from now, may look entirely transformatively different. And if we do not move forward with the pace that matches that pace of innovation, we may find ourselves in a situation where adoption is poorly of technology is poorly misunderstood, misused, presenting security and reliability risks to the grid. Even if it's just an adjacent non-SIP standards, for example, jurisdiction or scoping environments like distribution today, doesn't mean that it's without risk, right? So this conversation and this effort needs to move forward. So Sites has an AI ML sub-team, and there's some very interesting insights and conversations that are happening there. We're trying to, again, break out of that mold, and really ask the tough questions, have the tough conversations, and potentially build into something that is a much larger or as large as Sites itself in its own initiative. And so with that, I'm not going to dive too far into that because I'm going to let Thomas talk about some of the insights we've had in that sub team. But I'll just remind everyone that it's an open volunteering effort. Next slide, please, Wei. And so that kind of leads me into this exactly. Just as a reminder, right? Whether you've been in this industry a short period or a long period of time, I like to remind everyone that NERC is a self-regulating. The North American electric grid industry is a self-regulating industry. NERC is a coordinator, an orchestrator of industry engagement. It doesn't work without your participation, and neither does Sites. None of our initiatives can be accomplished without diverse perspectives. We have technical professionals, engineers, security folks. We have executives, VPs, directors from vendors, research groups, labs, regional entities, utilities of every sort. And it only works because of that, right? Because we are challenging ourselves to ask the difficult questions and move that needle. So your participation is anyone who's interested, please contact me by my email. And with that, I'm going to turn it over to Thomas.
All right, awesome. Thank you so much. And I appreciate all the work the Sites and NERC has already put together to get this conversation started. So my name is Thomas Peterson. I'm with GE Vernova. I am the vice chair of the Sites subcommittee and currently leading the AI ML subcommittee, specifically looking at how we can make a recommendation and suggestion back to NERC and FERC to help provide guidance in this space. So next slide. Excellent. I'm going to match this up here. So why are we doing this, right? As it was alluded to, there's this opportunity for us to actively engage the AI uptick and look at how we can operationalize AI in our workspaces, in the control centers, and both from the entire life cycle of generation, transmission, distribution, all the way out to the endpoints, et cetera. So we want to take a look at the markets. We want to look at extending the machine learning beyond the control room where a lot of it's used and take it to stakeholders beyond the grid operators. So how can we extend that out? And we need to do that responsibly. So we understand that the utilities that we have out there are stakeholder driven, shareholder driven. Some of them are private, some of them are co-ops, some of them are municipalities, and people are wanting to do more and more with less and less cost, and they're looking to drive efficiencies throughout the entire life cycle of energy management. So One of the key challenges everyone in our field is facing is how do we take all this diverse and emerging data, and how do we make it actionable and understandable for folks? Slide. So we briefly touched on traditional machine learning versus what we've currently done in the past. So a lot of it is physics based. A lot of it is math based. Machine learning. We can look at mean, median, mode stuff from a long time. We've been doing a lot of this stuff. So we can start creating forecasting, fault detection, and we can actually start looking at statistical outliers and creating a magnifying lens to hone in on those, and then use some of that to start doing predictive modeling, with a lot of different overlays. So where we want to get going to, obviously, is taking a lot of that math data and turning it into new concepts, new insights. How can we, what would be new, what would be novel for us to consider? And so what we want to do is take those models that have been developed outside of our industry, for example, ChatGPT, Claude, Grok, etc., and use those tools to help tune them to our industry. So we can look at massive data sets, etc. Next slide, please. So current use cases, and I think this should honestly be current use cases for ML in grid operations. So traditionally, we've used machine learning for short-term and long-term planning. We've looked at it from an asset management, from a GIS management perspective. We've even gotten to the point of vegetation management, rate and growth and prioritization of foliage, and some of those things as we think about the 2003 blackout. And we've also looked at, how can we prevent some of those natural things, some of those, really resource intensive measurements that put a lot of technicians and engineers in the field. How can we use ML to help us with those? Additionally, we've, like Wei was talking about, from an EMS transmission modeling perspective, we've been able to use machine learning for weather demand planning, demand forecasting, those kind of things. A lot of that whole shift left of energy management from West Coast to East Coast and follow the sun kind of energy management. In addition, we've been looking at DMS outage management for distribution and the last mile kind of planning as well. And then one other area that's kind of the current use case for some of this, and where it starts touching into AI a little bit more, is where we can start doing growth and demand forecasting based on population. So we can start doing population demand forecasting, commercial data centers, things like that, if we happen to have prior data on some of those demand usages. And then, of course, alternative energy adoption and that kind of modeling. All right, so where are we today? Next slide. So generative AI is already pervasive throughout a number of our industries here in the US, Canada, and the rest of the world. And it is entering our industry from an energy management perspective. But due to a lot of various constraints, etc., we already know that the usage is early stage. So some of the things that we've been looking at is what would be low risk opportunities to engage AI. So one of those areas is we have to get away from the massive amounts of documentation on all of the hardware equipment, and outage management, crisis management, things like that, right? How can we quickly find information about particular parts and things like that? Additionally, We know that we've got a lot of logs, a lot of SCADA logs, a lot of EMS logs that are coming in. How do we get through that pile of data quickly? And we already have folks summarizing and synthesizing a lot of reports to help out with that as well. And how do we manage, structured and unstructured data and make it meaningful for us as well. So, in a nutshell, today we're basically using a text-based assistant to augment our normal day-to-day jobs, which is totally fine, but we have opportunities to do more with that. So next slide. So from a potential for using generative AI, we already know that we want to take all that ML data and convert it into a form of plain language. So a couple of those future use cases, we need to create novel and new insights into those super large data sets. With our instrument everything, we do run across this exponential existential data management problem. So some of those things that we're looking at to leverage AI for is synchrophasor data, forecasting outages, real-time control center support as well. We do have a really cool opportunity, as you guys may know, about cyber and our defense of our power grid. So, we've got, the opportunity for advanced cyber control center defense tools, threat hunting, log analysis, advanced end user behavior analytics, how we could make adaptive firewall configurations to adapt to emerging threats, change management, and how we could get user permissions to be dynamic, and deal with more rights management, role-based access control. And what does AI look like as a change management authority, specifically when it comes to cyber defense? And additionally, of course, we could look at advanced data loss prevention analytics and sensitive information awareness. So as information is emerging, what actually becomes sensitive is also dynamic. And what if we were able to take a look at leveraging AI to say, do you think this is actually sensitive? Is this actually competitive? Is this confidential? So, and then we have the opportunity of bringing together physical and cybersecurity integration opportunities. So, if somebody is randomly swiping badges, and we were able to then bring in facial recognition, as well as somebody, trying to, break in or use cyber tools internally or even externally, we could do a lot more correlation of that information. Next slide. So what we are looking at is agentic AI. So how can we bridge traditional machine learning plus create a human interface and bring together all these different inputs into this? So much like how the human mind, we reference all kinds of different libraries, and we're taking inputs on our sensors and our sensory at all time. Where could we, bring all these things together? How can we partner and ask questions, externally process, and then have, this the system be able to pull from all those same kind of sources that we would naturally want to start pulling from. So, how can we create this like intuitive smart assistant, layered on top of all this massive data sets and all these different sensors and input? So next slide. So talking about multiple input types. So here's an example of a bunch of the grid data, the language data, the audio data. What would it look like if we knew that something was listening in our control center on one side of the room, and another side of the room was also talking about something, and all of a sudden the humans themselves weren't talking, but an AI was listening and said, "Hey, by the way, we think there might be a correlation on the other side of the room for what's going on." And what happens when you've got two control centers on two sides, right? And if you had one side of the control center trying to talk to another side of the control center, or even disparate control centers across a region, what would that look like to start aggregating that data? right? And what would it look like to have dispatch support for that as well? And what if a new model could be created, illustrating a new problem and visually create a, crisis or incident model specific to what everyone's trying to talk about, right? So, as we think about how this could up level our conversation. We've got a number of domains in the energy space. Like I mentioned, we've got generation, transmission, distribution, markets. A lot of people know about, and the operation space. But we've got new emerging areas such as storage, service providers, and now customer. So how do we take this massive amount of data out of the control room and then take it up to make business support and market support stuff? Next slide, please. So I briefly touched on voice agents and dispatch support. Consider it like a co-pilot or wingman kind of opportunity. Someone who's paying attention, checking the corners of the room while you are focused on what you're doing. You're working, but then all of a sudden it has a new insight. Oh my goodness. Did you realize you just said this? Did you realize they're talking about that over there? And how can we correlate that even in intense situations or a crisis situation? Next slide. So part of what we're looking at is Gen AI serving as the missing link between human interactions with large data sets, and translating that into actionable data. And so, and having that actually provide clarity and not just more noise in the room. And I'm just kind of quickly try to wrap up here. Next slide. We understand that there's a lot that's out there. We understand that there's opportunity for things to go awry. We understand there are risks. We also understand that there are model updates and a bunch of other things going on. So we are proposing that we have guardrails put in place. So just like training a dog, it's training the human as well, right? So you have to train the human to train the dog. And so, people go to puppy training or whatever, and they think, oh, I'm here to train the dog. No, you start with the human, right? And then you're able to keep the human in the loop. So we've got a number of challenges that we understand that are out there, and we understand there's a lot of risks. So this white paper is looking to start the conversation and have FERC and NERC. We're recommending that FERC and NERC step up, provide some more guidance to the industry, including OEMs and partners that are leveraging this as well. Next slide. So there's this request to explore and collaborate. Sites is one of those forums for that collaboration across our industry, both at the operator level, the utility level, the OEM level, markets level, as well as the regulatory level. So we do encourage you to join the conversation and to help us shape the future of AI and grid operations. Here's our contact information. Yep, go ahead.
Go ahead. Sorry, Thomas, I didn't want to cut you off. Go ahead.
Oh, I was going to say, and I guess at the very end, I'm sorry we don't have time for Q&A, but here's our contact information if you want to reach out and ask further questions.
Yep. Well, Thomas, Wei, and Larry, thank you so much for this fascinating presentation. I think, Wei talking about or introducing the white paper, and then Larry, talking about sites, and then finally, Thomas, you talking about the different opportunities in the Gen AI space, be it agentic AI, be it multimodal AI, and so on. So it's really exciting. And I think if I can quote probably Wei or Larry, he mentioned that the technology today may not be the same in the next 2 years because this Gen AI is moving at such a fast pace. So it's really interesting how things will evolve in the next couple of years. We have maybe about 5 or 10 minutes for Q&A. So there are a few questions, as well as I want to start off with one question. And this is with respect to Gen AI, and I really appreciate all the work that NERC is doing in preparing the white paper as well as through the site subcommittee. And since NERC has a pulse on the industry, how this technology is moving, I just want to get a sense of where does the industry see Gen AI technology right now? I'm assuming it is at a very nascent or very early stage. And I just wanted to get your thoughts on what you've heard from NERC as well as from the industry.
Larry, can you share some insight here?
Yeah, apologies. It's I would say it's as Thomas and Wei pointed out in the BPSA white paper, as far as and what discussions we've had in the sites AI group that Thomas just relayed. I'd say generative AI usage is in a very, very early stage. It's I recently attended Distributech and had a lot of conversations with a lot of vendors on the technology that's being developed, and it's predominantly the use cases and technology are centered around machine learning type model usage and development, and very, very, very little generative AI usage. And that's kind of prominently why I think Thomas's slides kind of then went into, well, here's what here's what the future might look like, because it's not yet being adopted there today. And so I do think that the future is agentic and or multimodal, where like this question that was just asked in chat about the usage of transformer models and short to medium term forecasting. I think it's a combination usage of those models, or multi-train models that are unlocking the language of energy data, which is our title.
Thank you, Larry. I'm just going to probably a couple of questions in the chat, so I'll just go through them briefly. First question is from Wei. This is from Ahmad from ETAP. He's asking, why is AI ML being applied only to contingency and stability studies? Are there any limitations that make AI ML less suitable for other types of power system studies?
Yeah, I think I'm so sorry. So I just listed here, so just for examples, the use cases, it doesn't mean it's only applied to condition analysis. So they have a broad the application or function. You could use AI and the machine learning tools, but RTCA or condition analysis is a critical function to certain utilities like RC or TOTOPs. They need to obey some running condition analysis or real-time assessment within 30 minutes. So they use condition analysis to identify IROL within 30 minutes as well. So this critical the functions, and also industry or entity have a lot of historic data, right? Because since the first time we have a EMS or a contingency there, so lots of historic data, easy for the tuning this model, also tuning these tools. So in the short, so it's not only we apply, but just my list as an example, definitely. But however, this contingency analysis is a critical function to the industry right now. Yeah.
Okay, thank you, Wei. Another question from Sarthak, which I'll slightly rephrase, is Gen AI transformer technology has been used in weather prediction to a very successful degree, and so is this something that could be useful for the grid midterm forecasting and short-term forecasting as well? Any thoughts or anything related to use of Gen AI for forecasting?
I'll take that real quick. So I absolutely think so. I've got a number of weather apps even on my personal phone, and there's a lot of different inputs that go into which model and how frequently the model updates. And there's also additional information we may not have, for example, solar storms or additional inputs that could adversely affect the weather that doesn't necessarily have any historical reference, right? And we've also got different changes, in one region versus another region. So I think Gen AI would also be a nice reminder. It could be a tool that help us remind, the people in the control room, like, oh, by the way, this looks a lot like something that happened maybe 30 years ago, 40 years ago, maybe something that somebody had experienced and reacted to. We call it, tribal knowledge, community knowledge, etc. And when you have new operators in the room that didn't experience that, Gen AI could, help revisit some of those topics or revisit some of that experience.
Right. Yep.
I'd just like to add, in the idea of using generative AI models for weather prediction, just be careful how those models are used. If you're using a large language model, for example, versus a transformer model that is trained on weather data, possibly because maybe it's sequential data and it's well suited for that. But if you're using a large language model and just bringing together disparate text-based information, then the large language model is not really predicting the weather. It's just predicting the next token of words, right? So they're not fantastic at actual data or logical prediction. And there can be a lot of hallucination in that. It's kind of like using a large language model today to go read, stock news articles and then try and predict, your next financial investment. It'll give you an output, but
Yeah, thanks, Larry and Thomas. And I think, given the nature of our industry where, there are critical decisions to be made and, there's a lot of things at stake here. So it is absolutely necessary that, these models, and as alluded by Wei and everyone, these models are thoroughly tested and validated before they are being deployed or before they are brought into the industry. More validation compared to maybe some of the other industries. We are at 11:10, that's Central Time. So I want to, I think that's the time that we had for the webinar. So I want to thank Wei, Larry, and Thomas for your time in presenting this webinar. Really appreciate all the perspectives that you presented. I also want to acknowledge the task force team before we wrap up. So I want to thank Rui Yao from Google. So Rui, if you could just turn on your camera. Then Adrian Maldonado from Argonne National Laboratory, and Cosmos from University of West Virginia. So thank you guys for helping set up this webinar, and I'm really excited to and looking forward towards setting up more of these webinars as well as all the things that we've planned. I see there is one more question in the chat box, but in the interest of time, what I propose is I'll take this question and I'll send it to the speakers and provide back the response to you. So thank you everyone for joining. This webinar is recorded and we'll have the recording available once we upload it to our YouTube channel. Stay tuned for more information, more news on the task force activities. And I wish you a nice day and great rest of the week. Take care all. Bye.
Thank you all. Good day.